Now, properly, we are going to run all the three methods of identifying abnormality, or all the three tests to test for normality of a given data. So the first thing we do is, now as I was saying in the earlier video, is that when a data is not normal or is not normally distributed, it will determine which type of test to use, whether it's going to be t-test or it's going to be Whitney u-test, or whether it's going to be ANOVA or whichever one. So it's going to determine which parametric or non-parametric statistical method of analysis. Now, I also want you to know that we do distribution analysis or normality distribution analysis on continuous variable. On continuous variable. We do it on continuous variable. So let's now go straight to how we run it. The first thing we do is to analyze. We click on descriptive statistics, then we click on explore. Now, there is what we call dependent and independent variable. When we say a dependent variable is a variable that will change. Is a variable that changes on our data. For example, gender will not change. Gender will not change, but age will change. Age will continue to change. If we have two groups, maybe we have two study groups, we have the test group and the control group. Now, the test and control group will not change, but the blood glucose you are running for each test, which is continuous, will change, will definitely change. So that's why we call it dependent and independent. Another reason why it is known as dependent. That's for the categorical, is that it is the variable that the other factors are being run upon. It's the variable that other factors are being run upon, such as we have the case and control study, like I said earlier, and we are now running PCV on both. That's the pack cell volume on both is a continuous variable. We are running the blood glucose level on both is a continuous variable. We are running the age, the weight, another example is the blood pressure. All those continuous variables are kind of dependent on the independent variable, which is the group. And the age, we can make our age the group, we make gender the group, we might make, in this our study, we can make the location the group, we can make all these categorical variable can be made the group upon a continuous variable, such as score and so on. So for the purpose of this class, we are just going to use gender as the independent. It does not depend on any of them. But measuring a parameter such as the score is depending on the gender. The gender is fixed. All the male and female gender cannot change in this class, but their scores are not equal because of their performance. So everybody's score varies, but your gender still remains. So that is why the score is dependent on the gender. So we now call gender the independent variable. So we put it in the factor list. I'll click on gender and put it in the factor list, while the one that is dependent will be checked into the dependent list. I repeat myself, the dependent variable, they are variables that will always depend on another variable. And because they depend on another variable, they might change. For example, the score in this class now, it will change upon your gender. Your gender will be your gender, but your score may not be the same. You may have two female in this class, but they have different score. So it means the score is depending on the gender. The gender is fixed, which is the independent because it is fixed. It is not depending on anything. It will come naturally. But the other variable will change, such as the score. Such as the score. So in this case, we look for another continuous variable, such as the age, just like the score. It's a continuous variable to check if it is equally distributed. So most of the time, not equally distributed, if it is normally distributed. If now, when it comes to distribution, we are always checking normal distribution in a continuous variable. You cannot say that if female and female are, we can't do that. We most of the time, it is better we use continuous variable to check for normality. So anytime we see an outlier, outliers make a, a group of data not to be normally um, distributed. So we've checked age and gender. Now the next thing to check is the plots. We click on plots. We are going to be clicking histogram. And we are going to be clicking normality plot tests. Normality, you can see it, normality plot with tests. So click on it, we check it, and we now click on continue. And we click on continue again. It will run it in no time. Now, this is where we are going to be making some analysis. This is where we are going to be making some analysis. We are going to be doing some manual calculation here. Now, you can see the skewness and kurtosis. For the skewness and kurtosis, we have a column here known as the statistics, and we have the other one, which is the standard error. Now, to get your Z value, you need to divide the statistics value by the standard error value. And that is how you get your Z value. And that is how you get this Z value we are talking about. This Z value we are talking about. This Z value we are talking about. That should be between minus 1.96 and plus 1.96. So let's see whether our data for age is normally distributed. Whether it is normally distributed. Now, we are going to run 0.4. I will punch it on the calculator. 0.466. You can see it. This is 0.466 divided by 1.014. And we have 0.45. We are going to have 0.45. If you look at it critically, we are having 0.45. We are having 0.45. So it means the Z value, the Z value the Z value for skewness and kurtosis I don't want to waste much of our time, that's why. Not to waste our time. So is our is 0 point. After dividing it, this was the value. This is the value we got, 0.59, which is around 0.5, 0.459. Yes, 0.459. This is the value we got. The value we got. Now going back to our outputs. Going back to our outputs. Going back to our outputs. For the kurtosis value, that's for female, we are going to see that we have minus 1.174 divided by 2.619, and it's equals to minus 0.44. It's going to be minus 0.44. So it's a 448, okay? So 448, this is the decimal places. So if you observe it, this is in between. If you observe, you notice that it's in between minus 1.9. It is in between minus 1.9 and plus 1.9. So we will say using kurtosis and skewness test, our data is well distributed. We are normally distributed in terms of a female. That's for age, and the data for age is well distributed in female. Likewise, if we run the same thing for male, it is also well distributed if you run this. Just because of time, so you don't repeat that. So I think you should just do that for practice. Secondly, we would like to run the Shapiro-Wilk test. Shapiro-Wilk test. Shapiro-Wilk test. For the Shapiro-Wilk test, it's quite easier because it brings out all data. The Shapiro-Wilk test is on the same output. If you see it on this test for normality. For the female, we state that it must be greater than 0.05. Let me show you again on our slide. If you check our slide, we state that it must be greater than 0.05. So basically, our data shows that it is greater than 0.05. You can see it's greater than 0.05 on both the male and female. So it's enough for us to say that the distribution of this data in male and female are normally distributed. And it's also evidenced by this continuous line on the QQ plot. You can see it is continuous. When our data is around the line, the straight line in our QQ plot, you can see that yes, it is in a way equally distributed. I keep mentioning evenly. It is normally distributed. You can see all the QQ plots. We should disregard this. As far as this is concerned. You can see even though there is an outlier, but it is still in a way it is normally distributed, irrespective of the fact that we have one outlier. I think it's just one, that of the 52 years, but it's not enough using other tests for us to say that it is not normally distributed. So with this type of tests, I can recommend that we use the normal t-test if you want to check for difference in mean, or you can use the normal ANOVA without going into a non-parametric test, which we are going to be discussing in our next class, the parametry and non-parametry analysis. So this is the end of the session for today, and I hope it helps, and I hope you all catch up, and I will employ every one of us to keep practicing, just keep practicing, and we will, a group of data will be provided soon, very soon, for us to be able to practice on the samples we have been doing. Thank you very much for today. See you tomorrow. God bless.